Hello students, so in this lecture we shall be discussing about clusters and magic numbers. Now we all know that nanometer is a few tens of thousands of thousands smaller than the human hair. A polycyst has the size of 1 to 100 microns, that is micrometer. Atom has a size of 0.2 to 0.4 nanometer. And when we are talking about nanomaterials, we mainly mean that the size is between 1 to 100 nanometers. Now coming to clusters. Now when the atoms, these atoms that I have just talked about, uh, these atoms, when these atoms they come and they cluster together, these atoms, and the cluster is actually a 2D cluster. Initially it is a 2D cluster, but as more atoms they come, they form a 3D 3D cluster with close packed arrangements. Now this is before any sort of formation of a crystal. Okay, so this shouldn't be confused with the crystal. So there has not been any crystal. Only the atoms have come together. Initially they formed a two-dimensional cluster, and later on they formed a three-dimensional cluster as well. So this is how a cluster is formed. Now this cluster has got a certain critical sizes. Uh, that means cluster it has some critical sizes. By critical size, what is meant is it has got a certain number of atoms associated with it. Now, these certain number of atoms, this gives the crystal it makes the crystal more stable, makes the cluster more stable. More stable in geometrically or in terms electrically as well. So also there is a geometrically more stable or in terms of electronic configuration, filling of electrons in different shells, they make this more stable. And that is why these numbers of atoms coming together and forming a cluster, they are also called magic numbers. Now, this magic number, initially it was observed in the case of gaseous system, in alkali metals, and also in thin films. Now, the number, the magic numbers, if we write, they can be 2, 8, 20, 40, 58, and lastly it's 92. Now, what makes these materials stable is the free energy. This free energy is lower, and that gives rise to its stability. Okay, now an example of this cluster is a very obvious example is the 60 carbon atoms. They come together and they form what is known as fullerene. This fullerene has icosahedral symmetry. With 20 regular triangular faces. Another good example of a cluster is krypton. In the large group of the periodic table. Now this is a noble gas. And being a noble gas, there are no strong chemical bonds formed. Either with itself or with others. But also, if the krypton atoms they come together, they're found to make clusters, and the number is 13, 55, 147, 309, 5, and so on and so 531 and 923. Okay, so this is one more example.